In this problem, we have the limit as x approaches 7 of some weird complex fraction because we have fractions inside fractions. I'm going to start by doing the plug-in method and taking x equals 7, plugging it in straight away. When I do so, I get 2 over 7 minus 2 is 5, so 2/5 minus 2/5 is 0, over 7 minus 7, which is 0. So this gives me that special form of 0 over 0. When I have 0 over 0, I either need to factor, multiply by a conjugate over a conjugate, or get a common denominator. In this case, we're going to get that common denominator. And why? Why do I know to get common denominator rather than multiply by conjugate over conjugate or factor? Factoring is usually reserved when you see polynomials, like x squared minus 3x plus 2, or x squared minus 5x minus 6, stuff like that. Conjugate's usually reserved when you see a bunch of square roots in there, but I don't see any square roots here. The fact that I see a bunch of fractions is what clues me into using a common denominator here. So I'm going to get a common denominator up in the numerator. This fraction needs the 5 that this fraction has, and this fraction needs the x minus 2 that this fraction has. So I'm going to say times x minus 2 over x minus 2. And I'm going to do the same thing here. I'm going to say 5 over 5. And when I multiply these things out, I get 10 minus 2x minus 4, all divided by the new denominator of x minus 2 times 5. So that'd be, let's just say 5 times x minus 2. Okay? Don't forget, this is all still divided by x minus 7. So we've got a lot of simplifying to do here. Let's start with the following. I'm going to say distribute the negative of this to the 2x and to the negative 4, giving me 10 minus 2x plus 4, so it's going to give me 14 minus 2x over 5 times x minus 2. One thing I also want to do is say to myself, I want to simplify this complex fraction. I don't like seeing fraction bars inside fraction bars. So what I'm going to do is I'm going to say x minus 7 divided by 1. One thing you probably learned way back in algebra is that if you have one fraction divided by another fraction, you flip this bottom fraction and multiply. So the a over b stays, but c over d becomes d over c, and we multiply. So the same thing is going to happen here. I'm going to say that here's my a over b, if you will, and this is my c over d. Now I didn't have an over, well, I know I'm covering this up. I didn't have this over 1 here. I had to put it there myself to remind myself, well, this is just c over some number 1. So c over d, this x minus 7 over 1 will flip to become times 1 over x minus 7. Now you might say, well, how does this help us? You look very closely. 14 minus 2x can factor out a 2, and not just a 2, but a negative 2. Let's factor out a negative 2 from this expression up above. When I do so, I get negative 2 times. Negative 2 factored out of negative 2x gives me just x, and negative 2 factored out of positive 14 gives me negative 7. So I now have this expression. If you'll notice, I can cancel these x minus 7s. This is going to be really handy for me because once they cancel, I can safely plug in the value of 7 I wasn't allowed to plug in before, or at least when I did plug in the 7, it gave me 0 over 0. But now that I've canceled that factor of x minus 7, no longer will I get 0 over 0. I'll get an answer that I want. So everyone plug in 7 here. 7 minus 2 is 5. 5 times 5 is 25. And then don't forget we have a negative 2 in our numerator for a final answer of negative 2 over 25.